All right, so one of these problems from last week, I believe it was this one right here, as we look at this graph, we said that it didn't pass the horizontal line test, right? But upon closer inspection, it actually does pass the horizontal line test. I don't remember whether it's the second one or the third one, but we are going to look at it now. So whenever we looked at this, we couldn't tell if this was a horizontal line in this section here in the middle. But if we test some points and plug them in, we're going to find out that it's not going to be horizontal ever. I mean, we can keep zooming in and it looks horizontal, but if we use the trace function, you see that this is still dropping. And every time we zoom in, I think last time we didn't zoom in far enough, but every time we zoom in, it hits a certain point where it'll stop dropping. But just because it stops does not mean we shouldn't zoom in further. And so if we look and notice that our number is not, see how the 1 is not changing here? If I zoom in further, you'll find out that the 1 changes. It is changing by such a small amount that Desmos is just dropping it off. But just be aware that if you have one like this where it's 1 minus something to the x to the third, it's still going to drop every number. But Desmos just doesn't have the capability of realizing that because it rounds our decimals off. This is probably like 1.00000000001, and so it just rounds it off to 1. But it is actually still dropping. So just be aware of that. Probably not going to give you one like that where it's so up in the air, but it's something to be aware of. No matter how far in I go, this is still dropping. As a matter of fact, if I click my tools and I say that my y-axis goes from, say, 0.99999999999 to 1.00000000001. That still didn't help, but it is what it is. Just know that even though this says 1, it's just rounding it off, but it's still dropping. All right, that's the whole point here. I don't think so. It's just a matter of just making it clear. It was this one. That's all. This one. Because we said that it didn't pass the horizontal line test, but it actually does if you use a trace function on it. Our calculators won't round that off if we were in school, but I didn't realize that Desmos was rounding it off, and I should have just thought it through, because even if I have 1.00001, that's going to be different than 1.0 whenever we cube it. But Desmos rounds the y off far more than it rounds the x off, which is weird. I don't understand that, but nevertheless, it's always dropping. So this one actually would pass the horizontal line test, so its inverse would be a function. Okay, so that's what we went off of. This last time we did that where we restricted the domain. And I believe this is where we left off. This is where we left off. Okay, verifying the inverse of a function. Let f of x equal 5 over 2x minus 4, and g of x equal 4x plus 5 over 2x. And it says use composition to verify that f and g are inverses of each other. So now we have to go through that process. All right, so what this means is we need to do the composition function of each one of these. So I need to do f of g of x. And what does that need to equal? Well, I'll tell you what it needs to equal. If you look back at the last slide that we did, that has to equal x in order for these to be inverses of each other. Everywhere I see an x in this function, I need to plug in all of this from g of x. If that equals x when we get to the end, then these are inverses. But then I also have to check g of f of x, so plugging f into g. So let's get started with f of g of x. Take all of this and plug it in for x. That gives me 5 over 2 times 4x plus 5 over 2x minus 4. Oh, dear. The first thing that I notice here is if I do 2 times this, it's like doing 2 divided by 2. So I'm going to cancel those 2's out just to make it simpler. So this is 5 over 4x plus 5 over x minus 4. Now, if I have just 4 here, then I can't just subtract x. Or I can't subtract the 4 from this because I need an x in my denominator. So let's get a common denominator of x, which means I multiplied the bottom, which was 1, times x. So I have to multiply the top by x. That's going to give me 5 over 4x plus 5 minus 4x all over x. Now I have 4x minus 4x. Those cancel each other out. It's now 5 over 5 over x. If I have a fraction in the denominator, I flip it and multiply. This just becomes 5. The top one stays 5 because it's really 5 over 1 times x over 5. 5 times x is 5x. 1 times 5 is 5. 5x over 5. 5's cancel. I'm left with x. So far, this looks like an inverse. All that just to get halfway done. Isn't that nice? So now we need to do g of f of x. And I want you to try to do that one on your own. And then we'll go over it in a second. So in this case, I'm taking my f of x and I'm plugging it in everywhere I see an x in g of x. I'm not going to deal with that. Clone it. Uh-oh, creating Dolly over here. If anybody knows what Dolly is, tell me what Dolly is and how it's relevant to what I just did, and I'll give you 5 bonus points on your last quiz. Yeah, Dolly. So you would have to send this in an email if you can figure out what I'm talking about. Heck, let's make it 10 bonus points. Dolly, and I clone this thing. due by midnight tomorrow. Got to do g of f of x. That's 4 times 5 over 2x minus 4 plus 5 over 2 times 5 over 2x minus 4 equals. So the first thing I'm going to do is cry. The second thing I'm going to do is I'm going to start by distributing this 4. So that's going to give me 20 over 2x minus 4 plus 5 over, and now I'm going to distribute the 2. 10 over 2x minus 4. Now on the top, I have to have a common denominator. So I need this 5 to have 2x minus 4 as its denominator. So I have to multiply the 1 that was down here times 2x minus 4, which means I multiply the top by 2x minus 4. That gives me 20 over 2x minus 4 plus, I'll distribute the 5 to both terms. That's 10x minus 20 over 2x minus 4 all over 10 over 2x minus 4. Combine my terms on the top. 20 plus 10x minus 20. That 20's cancel. I'm left with 10x over 2x minus 4 over 10 over 2x minus 4. Now I have a fraction over a fraction, so I flip the bottom and multiply. Gives me 10x over 2x minus 4 times 2x minus 4 over 10. 2x minus 4 and 2x minus 4 cancel. 10x divided by 10, the 10's cancel. I'm left with x. That was fun. I enjoyed it. So now, because both f of g of x and g of f of x equal x, then f of x and g of x are inverses. Like and subscribe.